Alright, let's solve this problem. So your task here is to copy down the question and let's proceed.
Alright, let's solve this example under the limit function. Evaluate the limit of function of x to be equal to 3x squared minus 6x plus 12 as x tends to 10 or approaches 10. Now, what is first? Your first task is to use our first method called the direct substitution method. So, to solve this is quite simple. Solution. So, what the first task here? My first task is to use what we call the direct substitution method. That is, anywhere I see x in this question here, I'll put 10. Right? So, in that case, I'll have that. I'll have, let's say, I have limit to be what? As x tends to 10 of this 10 x squared minus 6x plus 12. So anywhere I see x here, I'll put 10. So the limit, we said using direct substitution method. So I have what? The limit as x approaches 10 to be what? 3 into 10 to the power 2 minus 6 into 10 positive 12. Hence, at this point, I will have 3 into 100 minus 60 plus 12. So the limit as x tends to or approaches 10 will become what? 300 minus 60 plus 12. Obviously, equal to 252 as my answer after solving this problem. So this is quite simple as ABC. So this has to evaluate limits of a function. Let's take example 2 under this concept.
Sample problem 2. Your task now is to copy down the question and let's proceed.
Let's solve this problem. The limit of x squared minus 1 over x plus 1 as x tends to as x tends to 1. The idea is that anywhere I see x, I'll put what? I'll put 1. So let's use alright, let's do our direct substitution method here and let's see what we have. So using direct substitution, I'll have that the limit as x tends to 1 to be what then? 1 all squared minus 1 all over 1 minus 1. 1 squared is also 1 minus 1 over 1 minus 1. I have what? 0 over 0. So I'm having what then? Is 0 over 0. So this is what? Indeterminate function or undefined. So this is undefined. I call it indeterminate function. So this is not the correct way of solving this one. So in this case here, you can't use direct substitution here. It's failures. So we have 0 at 0. So hence, what do we do? At this point, we improvise, right? In the sense that in mathematics, there's what we call difference of 2 squared. You know, we discussed some basic tricks in mathematics. We discussed the rationalization, factorization, expansion via Bellman theorem. I should have included difference of 2 squared. In mathematics, there's what we call difference of 2 squared. If I have a squared minus b squared, we call it difference of what? 2 squared. It's having a square, having a square. So they are different. We call it difference of what? 2 squared. What is the mathematical expression of difference of 2 squared? We express as what? A plus b, a minus b. This is the what? Mathematical sense of expression of what? Difference of 2 squared. So I'm going to apply this concept here. Alright. So let me improvise. Instead of solving with this substitution method, I'll use another method. Alternatively, I can solve this one as saying the limit of x tends to 1 I can express the same what? X squared minus 1 squared. 1 squared is still this 1. X squared is this all over x minus 1. Difference of what? 2 squared. So I'll have what? X plus 1, then x minus 1 as the expression for difference of 2 squares. Right? So all over x minus 1 for the denominator, the limit as x tends to 1. So the limit as x tends to 1, at this point here will be equal to, observe, this can cancel out this, right? This can cancel out this, and therefore what? X plus 1. So x plus 1. Hence, at this point, anywhere I see x, I'll put 1. So I'll have the limit of x tends to 1, or according to 1 be what? 1 plus 1. Hence, 1 plus 1 is what? 2 as my final answer after solving this concept. So when it comes to limits, we avoid getting what? 0, 0. So in the case where having 0 and 0, we must improvise. Apply that method to solve the problem, which we have just done now. Let's take one last example and end this concept of the substitution method, right?
Finally, let's take a last question on limited function, and your task here is to copy down the question as we proceed.
Alright, let's say we are how to solve this problem on limits. So how do you solve this problem? Our first task is we usually say is what? We should use what? Direct substitution method. So using direct substitution, I'll have that what? The limit as x tends to 2 will be what? 4 minus x is here is what? 2. That becomes 2 all squared all over, I have 3 minus the root of what? This is 2 all squared plus 5. At this point, I'll have 4 minus 4 all over 3 minus root 2 squared is 4. 4 plus 5 is what? 9. Hence, I'll have 4 minus 4 all over 3 and 3. Root 9 is 3. I'll have 0 over 0. So this is what? Undefined, or we call it indeterminate function. So our task here is what? To improvise, as we said for this one. Look for another way of solving this one. Obviously, when to solve this one, I will apply what? The concept of rationalization. If I say I should take the limit of 2 squared for this one, I'll have what? X plus 2, x minus 2 for this one. But it can't just not anything down here. So I need to apply the limit of 2 squared to solve this one here. Hence, I apply what? The concept of what? Rationalization. So, alternatively, I'll have that what? I'll have the limit as x tends to 2 to be what? 4 minus x squared all over 3 minus root x squared positive 5. I have it this way, right? So, we're going to what? Rationalize. So, rationalizing, I'll have that. So, what do we want to rationalize? We want to rationalize what? The denominator, right? So, I will multiply numerator and denominator by the conjugate of denominator. Because it's all about this in a previous technique. So, I'll have 4 minus x squared all over 3 minus root x squared plus 5. So multiply this and this by what? I'll have this. Multiply numerator and denominator by the conjugate of denominator. That becomes 3 plus root x squared plus 5 as into 3 plus root x squared plus 5 as the conjugate. So hence we expand using what? Binomial theorem as we just discussed in technique. So pick out the first term, which is 4, multiply by all the term here, 3 plus root x squared plus 5. Pick out the second term, minus x squared, into all the term here, 3 plus root x squared plus 5. In this manner, I have this all over the second term, which is this one. Now 3, first term here, all the term here, into 3 plus 3 plus root x squared plus 5. Second term here, which is this, minus root x squared plus 5. The second term here, into all this term, 3 plus, alright, 3 plus root x squared plus 5. Now listen please. You don't need to expand this, please. Yes, you don't expand this. I the conjugate of what? Denominator. Hence, I'm expanding what the denominator, not what? Numerator. So take this back to this. I'll have this mark is this. So take it back to this. 4 that becomes 4 minus x squared into 3 plus root x squared plus 5. I have this all over. Now we have expanded the denominator. I told you why. Because we took the conjugate of the denominator. If I take the conjugate of numerator, I will expand numerator. But in this case here, I took the conjugate of what? Numerator. So I will expand only numerator, not sorry. I took the conjugate of denominator. So I'm only expanding what the denominator, not numerator. If it's that I took the conjugate of numerator, I will expand only numerator. But in this case, I took the conjugate of denominator. Hence, expand what? Only what the denominator. So in this case, I will have 3 times 3 is obviously 9 plus 3 times all this becomes 3 root x squared plus 5. I have this minus root this times 3 becomes minus 3 root x squared. Alright, so I have 4 minus x squared into 3 plus root x squared plus 5 all over 9 minus 5 is what? 4. I have 4, right? Then what? Minus x squared. Obviously, this and this report cancel out. That is what? Sorry, x tends to what? 2. At this point, I'll have 2. So limit as x tends to 2 will be what? 3 plus root x squared plus 5. So using 2 here, I'll have the limit as x tends to 2 will be equal to 3 plus root 2 all squared plus 5. Final answer, I'll have 3 plus this is 4 plus this is what? 9. Root 9 is what? 3. Hence, my final answer is what? 6 due to the surface of this, I have 6 as a final answer. So, thanks for watching.